Good morning, good afternoon. My name is Goya. Thank you for joining us. Some of you are maybe new to the webinar, and some of you, as we appreciate, are repeat visitors of our webinars. We try during the course of the year to bring educational webinars to you. As such, where today we will be talking about component obsolescence, and it's our honor to have Dr. Peter Sandborn once again join us from University of Maryland and CALCE, where CALCE stands for Center of Advanced Life Cycle Engineering. And believe it or not, Dr. Peter Sandborn teaches a course, and there are people that are getting their PhD in this field. So we're going to go through the webinar. During the webinar, as housekeeping, you can ask questions. Please use the window here to ask questions. Both myself and my colleague Milad, he's our sales engineer. We're both located in Santa Clara. This is the headquarters of the company. We'll try to address all the questions at the end of the presentation. Most probably we will not get to all of your questions, but please email them to us, and we will go ahead, we'll capture them, and we will then be able to answer them individually by email to you. The presentation will be sent to you after the webinar, and we appreciate, obviously, a survey question at the end of the webinar because the intent is to do better and better and improve on these. Now you can put a face to my voice. Again, my name is Roya. I'm the Director of Sales, and I'm joined here by my colleague Milad Shiraz, and he's our sales engineer. I'll do a very short introduction to SILICONEXPERT, and it's followed by Dr. Peter Sandborn's presentation, and then I will do a short demo of our tools, and specifically how the data that we're talking today is related to what we bring into the tool and how you can access the risk analysis or the obsolescence forecast. And then at the end, we will have the answers, questions and answers. So who is SILICONEXPERT? We've been in business for 15 years. We're headquartered in Santa Clara. And leading OEMs, such as some of the participants in this webinar, distributors, suppliers, and EMSs, again, part of our audience today, you use us daily. Experts come to us because they are searching for parts. They're searching for data. And our database, which focuses on the electronics vertical, is composed of almost 300 million components, and it's empowered by our software tools. We also offer integrated solutions, and we also offer professional services. We have over 400 engineers, and they are our employees. We've never subcontracted this out. SILICONEXPERT basically built this database from scratch. It did not inherit a legacy database. So again, everything in the database is down to an orderable part number. Because we focus on the electronics vertical, not only do we bring new products that are mountable, but non-mountable products as well. But again, focusing on the electronics vertical. So not just about ICs, integrated circuits, but passive electromechanical, and also non-mountable products such as cables and wires, computer products. It's all in our database. We bring up to 42 parametric values per product line. And specifically, again, for this webinar, we'd like to bring your attention to how we capture the risk analysis and what algorithms we have built in conjunction and collaboration with the University of Maryland to be able to scientifically have forecasting for obsolescence. In the database, you will also find the regulation data that we track. So I'm sure all of you know it's a headache with the environmental compliances. And every region in the world is introducing new compliances, and we track that data. So data such as REACH and RoHS and conflict mineral, and all the compliancy along with the material declaration and supporting documents. We also offer crosses, and that's obviously a very important feature, and a point of data, because no one wants to be stuck with a sole source part. So we also have parametrically derived cross-references for millions of parts in the database. Specific to what we want to focus today, as you know, your companies, places that are your employers, your enterprises, you need to be proactive. You can't just react to obsolescence. Reacting to obsolescence without a plan is a very costly matter. So together, again, with Dr. Peter Sandborn and CALCE, University of Maryland, we've developed algorithms to forecast the obsolescence risk. And then you can actually see these analytics that are seamlessly integrated into our solution. With that said, I will now pass the ball to Dr. Peter Sandborn. Dr. Peter Sandborn, it's my pleasure to have you join us once again. So I will go ahead through your presentation. Let me know when you're ready, and I'll just click next, and we'll go through your slides. Thank you.
Okay, we're ready. I guess we can go to the very first slide. I'll try to refer to them by the slide number, which is 9, I think. There we go. Okay. All right, so thank you for the introduction. I'm a professor in mechanical engineering at the University of Maryland and part of CALCE. And very quickly, CALCE is an organization of about 100 people that is focused on 2 things. It's reliability of electronic systems and then sustainment of electronic systems, sustainment including obsolescence management, counterfeit part management, prognostics and health management of systems, maintenance optimization, and things like that. So today we're going to talk about managing component obsolescence. So let's go to the next slide. Slide 10, there we go. This is the textbook definition of obsolescence. So it's defined as the loss or impending loss of original manufacturers of items or suppliers of raw materials, items and raw materials. And what we're concerned about here is electronic parts, although people work to manage obsolescence of a lot of other things too, but electronic parts are the primary one. Okay, in the world of obsolescence of parts, usually this is referred to as DMSMS. You see at the bottom of the slide here. Diminishing manufacturing sources and material shortages. If you want to search the web for materials on obsolescence management, use the DMSMS acronym. Don't use obsolescence. You'll find the right stuff under DMSMS. So let's go to the next slide. So this is really the problem in a nutshell. Probably lots of people out there on this call know the problem very well, but we'll go through it here very quickly. We're dealing here with what we call sustainment-dominated products. These are products and systems where the long-term support costs usually significantly exceeds the cost of procurement of the system. And this is fairly true for lots of safety, mission, and infrastructure critical systems. These sort of things are airplanes, military, medical, electronics, telecom infrastructure. You see other things there listed as well. So these sorts of products or systems are manufactured for a long time and supported usually for even longer. And this says 20 plus years, but a lot of these systems are 30 or 40 years support. So click it one more time there. There we go. So the deal with these systems is that they're all subject to really stringent qualification and certification requirements. So it means that you can't just change things. Okay, so a newer part comes along, you can't say, oh, I have a newer whatever part, I can simply use it as a replacement or a spare for an older part. In most of these systems, you can't do that, right? So there are prohibitive requalification costs, and some of these things are truly prohibitive. Changing out one part on one card in a large system may mean you're requalifying the whole system in sort of worst case. So click it again. So next, this type of obsolescence occurs because these products don't have any control over the supply chain for key parts. Okay, so usually in electronics, obviously it's things like cell phones and stuff like that that drives most of the supply chain here. And for the kind of sustainment-dominated products we're talking about, their volumes are so small that the vendors of the parts may not even have an interest in selling to them at all. So there's no way to drive the market here for the parts to stay around longer. Click it one more time. We call this an involuntary type of obsolescence, since these products are generally sort of forced to change to remain manufacturable and supportable, even though they don't necessarily want to change. Either the customer or the manufacturer supporter don't want to change, but they're forced to change. So click it one more time. So this is an example. You can find this sort of a curve for lots of kinds of parts. Okay, I've got it here for linear regulators. The vertical axis is the procurement life. That's the amount of time that the part is available from its original manufacturer versus the introduction date, which is the horizontal axis. And you can see that if we'd sourced linear regulators out about 1990, we would have sourced parts that would have been around from the original manufacturer for maybe as long as 20 years. Okay, by 2008, the mean procurement life of linear regulators was something like 2 years, maybe even less than 2 years. Not every part looks like this, but a lot of parts do, and that's the problem. So let's click it again. So the next slide here shows the magnitude of the problem. These are all counts you see on the right-hand side here, 2010 through 2013, of the number of parts that have been discontinued by manufacturers of electronic parts. And on the left-hand side, you see the 13 and 14 numbers by category of part here. The numbers flow up and down a little bit, which is not necessarily a significant trend in the fact that they're getting to be smaller. It's more a case of how you count parts and how you're counting up versions of parts and things like that. The point on this slide is that it's a lot of parts, okay, and it's going to be a lot of parts in the future, so we're not going to see these numbers drop off precipitously at all. So let's go on to the next one. So the next slide here sort of shows the problem. This is a surface ship sonar system from the U.S. Navy. Here you have a system where design began back in the mid-1990s, and by the time the first system was fielded, 70% of the COTS parts, at least, were already not procurable from the original manufacturer. And by 2007, you see in this graph, it's nearly 100% of the COTS parts are not procurable. If this was the extent of the problem, this would be reasonably manageable. Okay, the real problem is, click it one more time here. The big problem is the arrow to the right here, which hopefully we'll get in a moment. So hit the return there. There we go. The problem is we don't know how long this system has to be sustained. This is the real issue. So the end of support for this system is a moving target. Okay, and in many of these kinds of systems, you find that they have life extensions, and they usually have more than one life extension. If you had a fixed place to buy parts to, you'd be in good shape, but that place moves. Okay, so this is the essence of the management of electronic part obsolescence. So let's go to the next slide. All right, so management strategies we put into these three buckets. All right, so there is reactive management, okay, which means that you're simply putting in place management strategies for specific parts when you find out you can't procure them. Okay, so most of the world lives in sort of a managed reactive mode. Okay, so for safety mission critical systems, military systems, they may have to have a DMSMS management plan. Usually the majority of that plan is specifying what is the process for reacting once you have an obsolescence event. Okay, so we'll look at a couple of reactive approaches here in a moment. There's also proactive down in the lower left. This means that you're opening cases on specific bad actor parts before the part is actually discontinued. You're not going to do this for every part. You're not going to go open these sort of cases for surface mount resistors. Okay, they're relatively easy to replace when you can't procure the one you've got. You're going to open this on, you're open cases for parts that have a significant risk of going obsolete, and when they do go obsolete, they're going to be a problem. Okay, they're going to take system software with them or other bad things. Okay, so proactive means as you have resources, you open cases before discontinuance and start to work them. Strategic, lower right, means you're actually planning the life cycle of the system. Okay, so this means you're probably planning design refreshes that will scoop together a whole bunch of part obsolescence events and resolve them all at once and bite the bullet for requalification if you have to do it. Okay, let me state one thing here is the strategic solutions, lower right, they do not preclude doing the other things. You still have to react between design refreshes and things like that. So these are not mutually exclusive. Let's go to the next one. So the next slide here talks about obsolescence forecasting. Okay, so if I have any chance at all of doing proactive or strategic solutions, I got to be able to forecast what's going on. I got to have some heads up. And so generally speaking, there's sort of two approaches here. There's short-term forecasting, which usually means you observe the supply chain for precursors to discontinuance. Okay, so these may be reduction in number of sources, reduction in inventory levels, maybe part price changes, and certainly announcements that are made by the manufacturer. There are other things you can look forward to. Okay, so these are usually short-term things. You know, within 12 months of discontinuance, you start to see these sorts of things show up. There's also long-term forecasting. This is based on generally data mining of the historical record for the part. Okay, you have to do both. So click it one more time. Here at the bottom, it sort of gives the strategy. Ideally, you're using long-term forecasting when you're far away and you're continuously monitoring the supply chain for the precursors. And then you abandon the long-term forecast once you see precursors start to show up. You need the long-term forecasting if you're going to do strategic solutions. Okay, the short-term is fine if you have the ability to be proactive and keep your ear to the ground and know what's going on. So let's click it again. So just to show you a little bit about long-term forecasting, because the SILICONEXPERT database has these sorts of approaches in. There's sort of two ways that people do this. Either they do it with what's called an ordinal scale. They set up a bunch of attributes of the supply chain and they weight them and add them and do a weighted sum of them. This is common. The accuracy sort of increases the closer you get to the actual obsolescence event. There's not a lot of historical basis for this, and you don't generally get sort of confidence levels or uncertainties in your forecasts this way. All right, so better ways are sort of at the bottom, which are data mining based approaches. The wonderful thing, if there's something wonderful about electronic parts, is that there has been a lot of them. Okay, so there's hundreds of millions of parts that have come and gone and are available in the world, which means you have a huge historical record. And you can make use of that. At least people who have the full database can make use of it, folks like SILICONEXPERT. And you can build sort of vendor and part type specific forecasting algorithms out of the historical record. The nice thing about this is you get things like quantifiable confidence levels and uncertainties in your forecasts. And depending on the volume of information you have, you can do lots of interesting things potentially. So let's go to the next slide here. So really quickly, won't spend much time on this, but here's back to linear regulators as just an example. Here's procurement life versus introduction date for the whole population of linear regulators that had existed and gone obsolete as of 2008, I believe. And actually the nice thing is that this picture, the wedge picture, has some structure. It's not a shotgun blast of points, and you can actually characterize it and calculate what the probability distribution is associated with procurement life for this part. Okay, so let's go on to the next slide here. And there you go. So thank you. This is the sort of thing you can build out of this. If you take annual slices of the picture on the previous slide, you can build yourself an ability to forecast. If you click it one more time, we'll get something to show up on the slide. There we go. So the way you would use this, for instance, if you had chosen a part that had been introduced in 2004. This would tell you that if that part follows the whole population of linear regulators, that it would stay around or be procurable for about 6 years. If you have sufficient data, you can do this on a vendor-specific basis. To the next slide here. Thank you very much. Click it one more time. There we go. That's very nice. So here's, oh, go back. Thank you. Sorry. Here's national semiconductor linear regulators. Okay, so if I have enough data, I can do this and build models that are specific to a certain vendor of linear regulator. Maybe I even build a model that's specific to a certain bias level associated with linear regulators, and I can forecast. Okay, so let's go to the next slide. So moving on here, we'd like to forecast things, but we always have to mitigate problems too. And so this is, what do I do when when I've actually found a part is obsolete and I need to procure it? So I have a whole list of possible approaches on the left. These are approximately listed from least expensive to most expensive. And people use all of these things. Okay, so they all exist. Click it once. We'll get a box that will come up here. Let's look just at a very common approach, which are lifetime buys. Lifetime buy is just what it sounds like. It means you figure out how many you're going to need forever, and you buy them before the original manufacturer stops production. Okay? A last time buy is a version of that, but you're not buying them forever. You're buying them until some point in the future where you're going to design the part out. So those are called bridge buys as well. So let's go to the next slide. So this is the way I explain lifetime buys to my students. I tell them it's like buying shoes. So I tell them that, hey, what if the last time you could buy shoes was Friday this week? Okay, so I say the first problem you've got is a demand forecasting problem. How long do you think you're going to live, and how fast do you use up shoes? Okay, so you figure out how many you're going to have to buy, how many pairs. The second problem you've got is you need to pay for all those shoes on Friday. Okay, so you can't pay for them over the next 20, 30, 40 years. You have to pay for them all on Friday. So you have a cost of money problem. Maybe you have to go to the bank and get a loan, okay, to roll out the money to pay for all these shoes. Third problem you've got is where are you going to keep the shoes? Okay, so some of these shoes are going to be stored for a long time. So if you keep them stacked in your backyard, chances are that the humidity or the bugs or the mice or something else is going to get to those shoes before you have to wear them. And then they aren't going to be wearable. So you probably have to store them in some sort of environmentally controlled way. Okay, and that's certainly true of electronic parts. Okay, and fourth problem you got is what if you outlive your shoes? So what if you live longer than you thought you were going to? You know, there's medical science that extends our life expectancy, and you end up living 5 years longer than you figured on. Where are you going to get shoes? Okay, and at this point we sort of say, hey, you may end up having to go down to the corner of your downtown area to the guy who's wearing the trench coat who opens it up and says, I got shoes, you know, and you don't know where they've been or what they are or if they're real, and he's probably charging a premium for them. Okay, so this is kind of the lifetime buy problem. So go on to the next slide here. So lifetime buys break down into really 4 costs. You got to buy them, you got to store them, hold them, inventory. You have to dispose of the parts that you don't need if you overbought. You have a penalty associated with underbuying the parts. So click it one more time. The problem with lifetime buys is that it's an easy concept, but they get very complex very fast. Okay, so I usually say the worst thing about lifetime buys is that they're easy for your management to understand. Okay, but they can get extremely expensive. Okay, let's go to the next slide. So a moment here on strategic solutions. So usually what people use is design refresh planning. Okay, in design refresh planning, the point is to find a plan with 0 or more refreshes in it that minimizes the life cycle cost of the system. Okay, I said 0 there because there are certainly systems and demand profiles for which the optimum solution is no refreshes, okay, which is great. Sometimes there are constraints on the system that won't allow you to do that, okay, and other times you need multiple refreshes. Okay, so basically what you do at a refresh is you are targeting keeping approximately the same functionality, okay, and performance as you had before. You're just trying to keep the system manufacturable and supportable, okay. So if you click it once, it'll bring up an orange box here. The challenge with refreshes is basically this, is you've got to determine the optimum design refresh plan, that's dates and content, what you're going to touch, that balances reactive obsolescence mitigation between the refreshes with the expense of doing the redesign. Okay, so things like lifetime buys get real expensive real fast once you figure in cost of money and you figure in holding costs. It stacks up. And pretty soon it makes sense to bite the bullet and refresh. And if you have other constraints on the system, you may have to do that anyway. So let's go to the next one here. So this is a quick example here on refresh planning. This is a tool called MoCA from CALCE, and this is a Motorola fire police radio system. The vertical axis on the plot there is mean lifecycle cost. Lower is better. And the horizontal axis are dates. And all the data points you see there, each one is a unique combination of refresh, dates, and quantity. Okay? So for instance, the red dots have a single refresh and they're plotted at the date of that refresh. The green triangles have 2 refreshes. Actually, it's plotted at the mean of the 2 refreshes, etc. All these are different. So these folks, you can see there's a gray line up at the top. This was the solution that they originally had, which was all lifetime buys. Okay, and it turns out that, yes, thank you very much. If you click one more time on this, we'll get a delta there. Okay, so the optimum in this case was a single refresh in 2011 for this system, and the cost avoidance here was about $33 million for this system. Okay, let's go to the next slide. This is part of a business case. Okay, so, and click it again here, so we'll get the pictures to come up. The point of doing this is that the folks who were managing this system knew that if they put a refresh anywhere, they'd be better off than just doing all lifetime buys. But they didn't have the ability to sell management on that. They couldn't sell the customer, which was their management. And they needed to build a business case. And so that's effectively what's been done here. And in this slide, click it once more. Here, we'll get another line to come up. In this slide, it's showing you the difference between all lifetime buys and a single refresh in 2011 with bridge buys to the refresh and then lifetime buys after. That delta is actually shown on the right-hand side of this as a probability distribution. So that's all the possible differences when you fold in all the uncertainties in future obsolescence dates and the uncertainties in costs and uncertainties in demand for this system. And I believe this also included uncertainties in end of support date. Okay, you get a solution like on the right. Okay, the mean is about 31 million. Okay, there's about an 84% confidence that you'll have a cost avoidance greater than 30 million if they would do the single 2011 refresh. And in this case, the customer did the single refresh in 2011. So let's go on to the next slide here. Okay, so bottom line is you have to do a couple of things. Okay, you have to understand the cost ramifications of your sustainment decisions. Okay, when you pick parts, you should be understanding what is the life cycle cost ramification of that choice. Okay, you have to decide how you're sourcing parts. Okay, you have to be able to make a business case for these decisions. Okay, and then last, you have to understand the state of management of your organization. So click it again, and we've got only a few more slides here. You want to be able to have sort of a total cost of ownership idea here. When you pick a part, it's not just the procurement cost of the part. Everybody on this call probably knows that very well. It's all these other things. You've got to qualify the part, maybe qualify the vendor. You have to manage the part, which may mean obsolescence management, and deal with these other things. So if you click it once again, look at a quick example of that here. These are simple surface mount capacitors. Everybody knows what they are. Let's go to the next one. How much do these really cost? All right, so click it again. So in this case, if I have a high volume of them, this is about 13 million parts, so high volume application. Here's what sort of the cost of ownership pie chart looks like for that capacitor. And these are 1.5-cent capacitors. You can see that they're effectively 22 cents a piece. Once you figure in the money I spend to assemble them, the money I spend to qualify their source and keep their source qualified, etc. Okay, if you click it again, we'll reduce the volume here. Okay, so now I'm down to needing about 13,000 of them, so considerable drop in volume. And now they're effectively $70 a piece is what that decision to pick that part means. And if you click it one more time, we'll drop down to something that's more like some military applications here, about 1,300 of them. They're $700 a piece. Okay, so you have to understand, what the cost of your decisions really is here. All right, let's click it once more, and we'll go on to the last couple of slides here. So the other thing we tell people to do is understand the state of their supply chain. Okay, so we like this metric, and it comes from the older SD22 documents. That's the DoD's DMSMS management guidebook. This metric basically puts all the parts that either aren't problems or problems that you have solutions to, and divides them by all the parts that could be problems. Okay, and you can break down the parts in different ways. This is how we break them down. You might have something slightly different. Okay, and the idea is to measure this metric for your systems. Okay, so if you go to the next slide, give some numbers. Really, the best practice programs can claim this thing as 90 to 100. Okay, in other words, they really have their arms around 90% or more of the parts in their system and understand exactly what their state is. Okay, and then you can see it sort of drop off from there. You don't want to be in sort of the 50% range. Okay, then you're sort of running on the edge if that's the case. Okay, and if you click it one more time, we usually say, well, if you're below 40, you maybe need to consider some other options. Okay, so the deal is you'd like to do this for particular systems. Some of the really state-of-the-art folks can do this metric for their whole database. Okay, so think about that. All right, click it once more. I'm running out of time here. So let me note that obsolescence management challenges isn't just about piece parts, okay? And it isn't just about hardware. Okay, software is at least as bad a problem, maybe worse problem than hardware. Okay, and maybe harder to manage. And you see other things there: chemicals, intellectual property standards. Other folks do manage these things. And even I want to point out the last one: people. Okay, critical skills obsolescence is a big problem, especially when it comes to managing software. You may lose the people you need. And they may not be replaceable. Okay, so there's more than piece parts here. And there's a whole host of other issues that fall into this problem as well that you can see here listed at the bottom. So one more slide, if you click it one more time. And let me just make the point here is those capacitors you saw that we did our example on, if you click it, these are in fact counterfeit parts. Okay, so that's another problem you got to worry about as well, especially when you're managing obsolescence. So, and I believe that's about it. My last slide is just some supplemental information. Actually, if you go to our website, there's copies of all this stuff there. If you're interested, or you're more than welcome to email me if you have questions. I'm happy to talk to anybody. Thanks.
Thank you very much, Dr. Peter Sandborn. I really appreciate it. I always enjoy the analogy with the shoes, and I try to use that in my household, but it doesn't go down very well with my husband. So my takeaway is always those bright red shoes, and I absolutely love it. But
you should try the shoe analogy with a 16-year-old daughter who says, "Dad, I can so get that. You know, I'll buy all the pairs I can get my hands on."
But it is a bigger problem with obsolescence, and I'd like to now walk through our demo just for a very brief and highlight some of the things that you talked about. So with that said, I'm going to, hopefully everyone can see my screen very soon. Okay. Some of the things that, while we're waiting, okay, here we go, that I want to point out from the slides that we saw, specifically to slide number 13 that Dr. Peter Sandborn showed, that actually listed the number of obsolescence parts. That was almost 500,000 parts in 2014. And as you said, Dr. Peter Sandborn, it's a problem that will stay. It doesn't decline. It's actually every year it could be rising. In 2014, SILICONEXPERT actually monitored those parts, and we found out that 500,000 parts went EOL, end of life, and had a last time buy. 60,000 parts were not recommended for new design. Now, the interesting facts are the majority of the EOL, end of life parts, were passive parts, so your resistors or your capacitors. But 25% of those were semiconductors. And that's where hopefully you have proactive strategies in place, because as we all know, semiconductor parts can be very costly. Now, we noticed that the spikes in those changes for life cycle in 2014 happened mainly in beginning of Q2 and beginning of Q4 of 2014. Although 500,000 parts were monitored for life cycle changes, again, an interesting piece is that only 34% of them did not have product change notification. And immediately after they had the EOL notice, 26% of them were flagged for last time buy. So this all ties to the presentation that we just saw from Dr. Peter Sandborn, and I just want to remind you that that presentation will be sent to all of you after the webinar. I know we're running out of time, so let's just show you. Obviously, SILICONEXPERT offers two solutions. One is our search tool, and one is our BOM manager tool. Let's just dig in on one of the parts. So there are many ways to search for a part. You can do it by product. The product tab signifies our taxonomy. This is how we have organized the 300 million components. And as I said at the beginning, it's not just about integrated circuits, but as you can see here, passive electromechanical and even non-mountable products like wires and cables and fasteners and even computer and office products. So you can search by product, you can search by supplier. We have over 15,000 suppliers in our database. You can do a parametric search or simply put a part number here. And the way we bring up the part number, it doesn't have to be a complete part number for search. It can begin or contain with. So now immediately at the dashboard level, you can see the orderable part number. As a reminder, again, everything in our database is an orderable part number. Who makes it? A description, the data sheet, a yes or no answer to ROHAS, again, the life cycle information, and now, as you can see, this part has gone obsolete. What are we going to do? We are going to proactively look for process. So let's click on this part. Every part is hyperlinked, and you can see now more details as we refer to this as our part detail page on the part. To Dr. Peter Sandborn's point, we also keep historical data. That's how we actually come up with the algorithm to forecast the risk analysis, because we go back with all the historical data that we have. So let's look at that risk analysis. So this is the algorithm, and you can actually download the paper that we have jointly collaborated with Dr. Peter Sandborn and University of Maryland. There's more to be seen here. But as you can see here, this part has 54% risk. And we don't just look at the life cycle. The way we have calculated this algorithm is based on these 4 elements. Okay, now this part has outlived its life, but can it be multi-source? So we're in good shape because this part from Fairchild can be crossed to parts from ST Micro and parts from Onsemi. And I'm going to go ahead and show you how to do the crosses. Is it still available in inventory? So although the part has gone obsolete, you can see that for the past 3 months, about 11 distributors have carried the part, and this is the average quantity on hand. So instead of reacting again, you can be proactive while you are making your strategic design out in order to replace Fairchild with a cross. For your immediate need, you can still find inventory on hand and procure it before it completely leaves your bill of materials. And then obviously the part is yes to RoHS, so you can see the RoHS compliancy here, and we also bring the complex mineral status of the part. With that said, let's now look at, also we bring, as Dr. Peter Sandborn referenced, counterfeit parts. So we bring all the reports that you need to be aware of from GIDEP, and GIDEP stands for Government Industry Data Exchange Program. And we also monitor for the supply chain risk, we monitor the counterfeit. As you know, during the tsunami or the Thailand flooding, there were spikes in inventory where the price went up, demand came down, and you have to really watch out for those counterfeit parts, especially during the natural disaster. Let's look at how we would do some crosses. So again, the part has gone obsolete. We can either do parametric crosses, or we can look here, and we give you the option, obviously, to filter. So you want to filter by active parts because you don't want to cross a part that already has gone obsolete to another obsolete part. So what we've done here is that now you can see that this part from Fairchild gets crossed to parts from ST and Onsemi. And to make it easy for our users, we have a cross type definition associated with the type of cross. What that means is the best type of cross is an A type of cross. This is to make it easy for you, the user. A means that it's a pin-to-pin drop-in replacement with exact form, fit, and function. And each code also has an upgrade and downgrade. So usually an A and B type of cross really doesn't take much engineering time because we've done a side-by-side comparison for you, which I will show you how you can conduct that. And it's either pin-to-pin drop-in replacement, and with the B code, it's still pin-to-pin compatible, but there are minor differences. The C, D, and F, we recommend highly that the crosses be looked at and further analyzed by the engineering community. You can take 8 of these parts per view, compare them side by side, where you can see the differences between the parts in different columns. The commonality between the parts are in one column, and from every page you can download any report basically and download the comparison. So if we look at this, it builds a very nice Excel spreadsheet for us with all the tabs that you saw on the parts details page. So you can see the differences in the summary, parametric difference, package difference, manufacturing, environmental, complex mineral, and as you may have seen, we bring also the inventory. We get feed from all franchise distributors on a daily basis, and we bring that. Few other things to notice here is the proactiveness of the tool. You can actually set up your alerts. So any type of PCN that you want to receive or supplier acquisition change or data sheet lifecycle change, just submit your email address. Every time there's a change, you will receive an email with that type of alert. That's on a part level. Same thing that I'm showing you on the part level can happen on a BOM level. So you create a project. Majority of bills of materials are in Excel. You will upload a BOM. And the tool is only concerned, at minimum, with a column where you can identify the manufacturer part number and the manufacturer. Majority of enterprises may have an internal part number, and you can map that to what we call a CPN, so you can keep the relationship. Obviously, to go through scrubbing, so you can do the scrubbing. We also have auto-corrected, so out of our exact matches, 25 parts have been auto-corrected. We look for mergers and acquisitions. So for example, on row number 61 of this BOM, the part number was correct, but the supplier was called Dale, and Dale became Vishay, or National Semiconductor became PI. From this, I know that we're running out of time. Let me just show you a few key things. So everything that, again, on a risk analysis that I showed you on a part level, you can actually download a report from here. You can do it either on your internal part numbers or on the manufacturer part number level. So if we do it on an MPN, again, it fills out a really nice spreadsheet, and you can see the risk data associated with this entire bill of materials. And here are the 4 elements that we track. You can see the life cycle, and then the overall life cycle risk, the overall ROHS risk, whether the part can be multi-source, and the overall multi-sourcing risk, and whether the part is found in inventory. And here is the algorithm that we have built based on these 4 elements that highlights where you need to really zoom and be proactive. So on row number, let's say, 95 of the original bill of materials, that's a high-risk part. And then you can take those actions that need to be corrected, so whether it's a cross-reference. The other thing that we also show here is how resilient is your product? Is your product going to live 5 years from now? How resilient is this product? We are showing you the risk associated if you were building this bill of material 5 years down the road, how many do you have today that has a high risk, and in 2019, how many parts have a high risk. I'm being flagged by my colleagues that we're running out of time, so I do like to give a few minutes to some questions and answers. And again, Dr. Peter Sandborn, thank you very much. We will obviously post the presentation, and all the users will have your presentation with the link on your website. And I appreciate that you've offered that you can also answer some of the questions.
So Dr. Peter, we have one question from one of our attendees. So the question is, in 2014, 34% of obsolete parts didn't have an EOL notice. Do you know why they didn't have an EOL notice, and how is this tracked and verified?
Well, so there's no legal responsibility for vendors of parts to issue an EOL notice. Okay, so first get that out of the way. Secondly, depending on who you are and what kind of contract you have with vendors, and if you're buying parts directly from the manufacturer, you can put in contract language that says they have to let you know with a certain period of time if they're going to end of life a part. That said, probably many of you out there aren't in a position to require that from your vendors. So there's no way to ensure that those notices will come out. I think using some of the tools like SILICONEXPERT can tell you, even when there's no EOL notice, that a part is close to discontinuance. But this is not real uncommon out there. That's all I can say. When we do our strategic refresh planning and things like that, we're putting in we characterize forecasted obsolescence dates as probability distributions, and sometimes things fall on the low end and sometimes things fall on the high end. But it's not a surprising number that 34% go away without notice.
Great, thank you.
And this question is for you, Roya. It's in the part search tool. Can you show us a material declaration as well?
Sure. So let's go back here, and let's, for example, pick a part, and this is a TI part. It's yes to Rojas, and we click on it. Again, and few things that you can see, the freshness of our data, right? We update our data, and we are so confident about the freshness and maintaining our data that we actually post when was the last time that we touched this data. So let's look at some of the environmental compliances. Again, our database is for every component that has data that is publicly published. So NDA parts, customized parts, ASIC parts, they will not be there. But let's look at the material declaration. So here's the chemical breakdown. And if the supplier has put out any supporting document, be it an MDS, be it a certificate of compliancy, this will accompany as a source to that part. So here, this is what TI has provided when it comes to the material declaration certificate for this part. I hope that this example has helped the question. But yes, so there are, as you can see, you can just go to the environmental tab, and you can see all the compliances. And for more information, you can go to our document center. And in our document center, you actually will see it's like a library. You can see which regions of the world are coming out with the environmental compliancy and how we're tracking that. Is there another question?
Yes, and this one is for Dr. Sandborn again. So this is a two-part question. With a product in the medical industry, the intended lifetime is often anybody's guess. Is this a factor in your modeling? Also, is procuring parts from the gray market included in assumptions as well?